want to use this example to explain the whole concept of the triangular law and the midpoints, isn't it? So how do we prove that three vectors form the sides of a triangle? Are you seeing that? Now here it is just sides of a triangle. It is nothing to do with the right angle triangle. Meaning there are cases where they will tell you to prove that these three vectors form the sides of a right angle triangle, isn't it? When they say sides of a right angle triangle, meaning you need to add one more identity, and that is the Pythagorean theorem, isn't it? The Pythagorean theorem, whereby the magnitude of one vector is supposed to be equal to the square of the magnitude of one vector is supposed to be equal to the sum of the squares of the magnitude of two other vectors, isn't it? That one when they are forming sides of a right angle triangle. But this is not a right angle triangle, it is just a triangle in general, isn't it? So a triangle in general, the first thing you need to identify for you to prove that three vectors form the sides of a triangle, the first thing you need to prove is the triangular law. The triangular law. The triangular law says that for three vectors to form sides of a triangle, then one vector should be equal to the sum of two vectors. Are you seeing that? One vector must be equal to the sum of two vectors. So if the triangular law holds, then those three vectors form sides of a triangle. Are we together? Meaning one vector must be equal to the sum of two vectors. It can be maybe vector A can be equal to vector B plus C, or vector B can be equal to vector A plus C, or vector C can be equal to vector A plus B. Either, meaning one vector must be the sum of two vectors. That is when the triangular law holds, isn't it? Are we together? So you have to check in which situation is the triangular law holding for these three vectors, isn't it? Meaning one vector must be expressed as the sum of the other two vectors. Then if one vector is giving you the sum of the two other vectors, then the triangular law is holding. Are you seeing that? So if you look at here, just check even for I alone. Here I is 3, here I is negative 1, not I mean here x is 3, coefficient of I, isn't it? X is 3, x is negative 1, x is 4, isn't it? So which ones do you add to give the other ones? You can see 4 plus negative 1 gives you 3. So you can see negative 2 plus 3 give you positive 1. So you can see negative 6 plus 4 give you negative 2. So it means the triangular law holds if vector A is equal to vector B plus. Are you seeing that? Have you seen that? Meaning if you add vector B plus C, you get vector A. Because from here, we have vector A is equal to what? 3i plus j minus 2k. Then if you look at vector B plus C is what? B plus C, what is your I? Negative 1 and 4. You have negative 1 plus 4i. Then plus, what is your j? Go to j. Coefficient of j, what is your y? Positive 3 and negative 2, isn't it? Positive 3 and negative 2, those are coefficients of j. Then what is your k? Positive 4 and negative 6, isn't it? Positive 4 and negative 6k. What do you get? So you get 3i, 3 minus 2, plus j, 4 minus 6, minus 2k. So are you seeing? A is equals to B plus C. Are you seeing that? So when A is equals to vector B plus C, then it implies the triangular law has hold. When the triangular law has hold, then the three vectors forms the side of a triangle. Are we together? The three vectors form the sides of a triangle. So if it was a right angle triangle, the next thing you need to prove is the Pythagorean theorem. But there is no right angle triangle. They will say that, isn't it? So after proving the triangular law, the next thing you need to check, once you've seen the equation holding the triangular law, it is what you use. Meaning A is equals to B plus C. So when you put the magnitudes, then this sign should be less than. Meaning magnitude of A should be less than magnitude of B plus magnitude of C. Remember, if A was equal to B plus C, then that is automatically telling you that magnitude of A is the same as magnitude of B plus C altogether, isn't it? This will be equal, yes. But now what about if magnitude of B is separated from magnitude of C, isn't it? Meaning magnitude of A must be less than magnitude of B plus magnitude of C. Must be less than. Are we together? So can you now get the magnitudes? Go and get me the magnitude start. What is the magnitude of A? The Pythagorean theorem, isn't it? Are we together? The magnitude of A is x squared, which is plus y squared, y is positive 1, isn't it? Plus z squared, negative 2 squared is just 2 squared, negative squared is positive, isn't it? What do you get to be the magnitude of A? What do you have? Square root of 14. You're supposed to have 3 point something. 3.7? 7.4, isn't it? Then get me the magnitude of vector B. What is the Pythagorean theorem? X squared, x is negative 1, isn't it? That is negative 1 squared plus y squared, y is positive 3, isn't it? Positive 3 squared, but both negative and positive, when they are squared, they will all be positive, isn't it? 4, z is 4 squared. What do you get? 5.10. Then get me the magnitude of C, the Pythagorean theorem. X squared, x is 4, isn't it? Plus y squared, y is negative 2. Plus z squared, z is negative 6. So what is magnitude of C? 7.4. After you found all this magnitude, then you check. What is magnitude of A? 3.74. Is it less than magnitude of B, which is 5.10, plus magnitude of C, which is 7.48, meaning that law has hold. Meaning what was given from the triangular law is what you use. Are you getting that? The triangular law told us that A is supposed to be plus C. Are we together? So it means when this sign, when you change it to negative, then you put magnitude for each and every vector. Are we together? When you change it to less than, I mean. Are we together? Is that understood? So you are using the formula you got from the triangular law is what you use. If you change this to be less than, then magnitude of each independently. But if magnitude of this is combined, then it has to be equals to, isn't it? Because this was equals to this, isn't it? But when they are separated, meaning it must be less than from whatever you got from the triangular law. What made the triangular law hold is what you use here. Are we together? So if it was a right angle triangle, is whereby you can now prove the Pythagorean theorem. A squared equal to B squared plus C squared, if that hold, isn't it? Isn't it? Are we together? Good, good, very good. Now after that, we've now seen the 2 is enough to show that they are forming sides of a triangle. Are we together? But now, what is now more important is the midpoint of those sides. There is a very long process of getting those midpoints, but I want to show you the simplest method of getting those midpoints. Are we together? The simplest method of getting those midpoints without straining. Okay? Now, how do we get the midpoints of those sides? This is how to get the midpoints of those sides. The first thing you have to know, what did we say? Use what you have here from the triangular law. What we have here from the triangular law. So from the triangular law, you can remember, we say when you have vector AB, it is always second minus first, isn't it? Meaning vector AB is B minus a second minus first. Are we together? It is second minus first. If you have, when you are now told, why is it second minus first? That is coming from the concept that all vectors are relative to the origin, meaning all vectors must come from the origin. That is why I am coming with this concept, second minus first. All vectors must come from the origin. Meaning if all vectors are relative to the origin, meaning vector OA will just be vector A, because origin is 0, 0. So if it is A minus, so it is just A minus 0, 0, which will remain with A. Are you seeing that? When you have vector OB, then it means that is just vector B, relative to the origin. All vectors must be relative to the origin. So the moment somebody gives you vector AB, it must be relative to the origin. Meaning for you to move from A to B, it must be A through origin, then origin you proceed the journey to B. Are you seeing that? Are we together? But now what do you see here? There is nothing like A to the origin, must come from the origin, must be relative to the origin, isn't it? So if you have AO, if you change the direction of the vector, it becomes negative, isn't it? So if this is AO, meaning it will be the same as negative OA, isn't it? Negative OA plus OB. But all vectors are relative, meaning OA is just vector A. So this is OA is just A, so it is negative A. Then plus OB is just vector B, so it is negative A plus B. So if you rearrange, you can see it is B minus A. That's why we are saying when you have vector AB, it is second minus first, because from the concept of all vectors being relative to the origin. Are you seeing that? It is from the concept of all vectors being relative to the origin. So it means when you want to draw this triangle, this is the concept you are going to use. You are going to use the concept of all vectors must be relative to the origin, meaning you must have a subtraction sign. Are you seeing that? You must have a subtraction. But this is what we have from the triangular law. So if this is what we have from the triangular law, we make it have a subtraction sign, isn't it? To make it have a subtraction sign, this is what you do. You can make B or C the subject of the formula. Meaning if you make C the subject of the formula here, it becomes vector B minus A. Are you seeing that? Are you seeing we have the subtraction sign? If you make C the subject of the formula, it means B comes this side, you have. When you make, no, it is not that. It is not that. See, it is the B coming there. See, it is A minus B. Yes. See there? Look at yes. If you bring A this B this side, it is negative B. So you remain with C. It is A minus B, isn't it? If you like, you can make B the subject of the formula. If you make B the subject of the formula, what do you get? See, C goes to the other side. So it is A minus C. So here we now have C is equals to A minus B. Now can you come and draw the triangle? Now look the way the triangle is sketched. I want you to look here because it is the sketch you are using. This method, the method of determining the midpoints are very long, it involves square roots and all that, and I'm trying to avoid that. That's why I'm showing you the shortest route. Are you seeing that? Are we together? That's why I'm showing you the shortest and the best way to deal with it. So if you draw a triangle like this, look here. What have we said? We've said all vectors are relative to the origin. Meaning if I have vector A, then I'm talking about OA, isn't it? If I have vector B, then I'm talking about OB, isn't it? Meaning in this triangle, this triangle is you are supposed to have the origin. Are we together? Are we together? So if you have the origin to vector A, so if this your triangle is maybe triangle OPQ, because the origin must be there. Are we together? OP. Nani, are you trying to get what I'm trying to explain? Or yes. Let me just use the letters you have here. I have vector OA. So if I have O to A, that is A. That is vector A. I use that as vector A, isn't it? Are we together? O to A. Like that. Then I use here. So I don't want to use the same A because there's something I want to explain. Okay? There's something I want to. So if I say this is P and maybe this is Q, this is origin O. So the origin O will imply 0, 0, 0. Are you seeing? So go back and check. Go back and check. What was your vector A? This is what I want you to check. What was your vector A? Look here. 3. X was 3. Y was 1. Z was negative 2. Meaning if you change this to be coordinate, it is 3, 1, negative 2. Isn't it? Are you seeing that? If you change the coordinate, it is 3, 1, negative 2. So if you're looking for vector A, OA, from O to A, so if this P is just A, meaning this coordinate is 3, 1, negative 2. Are you getting that? OA. So for you to get vector A, it is O to A, meaning this is vector A. Tuko pamoja? It is this coordinate minus this coordinate, meaning this minus 0, you just get A, isn't it? You go to the next one, what is your vector B from here? See, we are using only A and B. What is your vector B? Negative 1, 3, 4. Negative 1, 3, 4, isn't it? So if you change that to coordinates, what is coordinates of B? Isn't it? So it means if you put this is to B, negative 1, 3, 4. Are you seeing? Are we together? Remember, look here. Remember, from O to B. From O to B is just B. Meaning from O to B is B minus O. Meaning this minus O, you remain with vector B. All vectors are relative to the origin. So you see OB. Are you seeing we have OB and OA? And what is C? C is A minus B. So now tell me, why are you getting C to be A minus B? Because it is for you to get C, for you to move from C, you move from here. So you can move from A to O, then O to B, isn't it? C is A minus B. What is A minus B? This is second minus first. See, A minus B means second minus first, meaning it was BA, meaning C was equal to BA, isn't it? Meaning from B to A. B that. Senior. Look at that. It is from B to O, then O to A. That is BA. So B to O, you are moving against vector B, meaning negative B. Are you seeing? Then from O to A, you are moving with that positive A. So negative B and positive A, see, it is A minus B. Are you seeing that? Good. Now look here. So this is now what we want to use to determine the midpoints. Once you've constructed this, now I want you to be very attentive here now. Should I have here? You can use this here. Look, I now want you to be more than attentive. Meaning the first thing you did was to make either B or C the subject of the formula, isn't it? We made C the subject to be C to be A minus B, isn't it? Once we made C the subject, meaning A minus B, we are going to have OA and OB. OA and OB, meaning you must put the origin. Are you seeing that? You must put the origin. So from origin to A, you get vector A. Then from origin to B, you get vector B. Are you seeing? Then you can see from B to A, meaning this is where vector C is. But you cannot see vector C, you follow the direction, isn't it? Are you seeing that? Meaning this side, which was vector C, it is not given as direction like that. You follow where there's a root, because all vectors are relative to the origin. Are you seeing how triangle is sketched? So I don't expect, the reason why I'm insisting, somebody will come and start sketching the triangle like this, ABC. This is not class 4 algebra, this is vector analysis. All vectors must be relative to the origin. Are you getting that? It is not this. You must make one the subject of the formula, meaning that one must be in terms of the other two. Are you getting that? One must be in terms of the other, and you must have the origin in that triangle, isn't it? The vector is the length itself and the direction, isn't it? Meaning these points has nothing to do with ABC. I've just used A that to avoid confusion, isn't it? This triangle can be triangle PQR. So that this is vector A, this is vector B, then vector C you get by following the direction which is there, isn't it? Because direction is relative to that origin. Are you seeing that? You must move from origin to A, you can see that direction from origin. Are you seeing that? From origin to B, you can see that direction, isn't it? But if you look at where you add A minus B, meaning if you add A minus B, it is always second minus first, meaning there you can see C was BA, isn't it? Meaning you move from B to A. For you to move from B to A, you cannot move here directly. You follow where there is a root, isn't it? Meaning this length is the length of vector C. Is that now understood? Are we together? So having understood that, how do you now determine the midpoint? It's very simple. The midpoint of this, isn't it? What is the midpoint of this line, of this OA? So it is x plus x divided by 2. How are you getting the midpoints? If you have 2 points x1, y1, z1, and a point x2, y2, z2, how do you get the midpoint? The midpoint is the point in the middle, isn't it? The midpoint is the point in the middle. So the midpoint is x1 plus x2 divided by 2. You get the middle x value, isn't it? Are we together? Then the middle y value is y1 plus divide by, you get the middle y value, isn't it? Are we together? Then the middle z value is z1 plus z2 divided by 2. Are you seeing you found the middle point? Are we together? Good. So what do we want here? Look here. We want the midpoints of vector A, isn't it? You were told to show that vector A, B, and C form the sides of a triangle. We've shown that with the triangular law and all that, isn't it? And we've sketched that triangle relative to the origin, isn't it? We've sketched that triangle relative to the origin. When we were looking that we must have a subtraction sign, is when we have second minus first. The concept of relative to origin must only work when we have subtraction sign here for us to see it clearly, isn't it? Nani, are you with us? Generally, isn't it? Good. So what is the midpoint of vector A? Midpoint of vector A is what? So it is x plus x, 0 plus 3 divided by 2. Senor, you get 3 over. So it is y plus y, 0 plus 1 divided by 2. You get 1 over. So it is z plus z, 0 plus negative 2 divided by 2, isn't it? Are we together? You get the value to be? Have you seen that it is very easy to get the midpoint of that vector A? See, this method is very simple and very direct, isn't it? Good. Go. What is the midpoint of vector B? Midpoint of vector B, you start. Where is vector B? See, this is our vector B. See there. What is the midpoint? See, it is 0 plus negative 1 divided by 2. X plus x divided by 2. You get the middle x value, isn't it? You get negative. Are we together? If x value here is 0 and x value here is 1, what is the x value in the middle? So it is negative a half, which is 0 plus negative 1 divided by 2. Then if y value here is 0 and y value here is 3, what is the y value in the middle? See, 1.5. See, 0 plus 3 divided by 2. See, that's the y value in the middle. 3 over. Then what is the z value in the middle? Z value here is 0, z value here is 4. The z value in the middle is 2, isn't it? 0 plus 4 divided by 2. Are we together? Good. You get z value to be? Go to the next one. Midpoint of vector C. Were you determining these midpoints are in terms of position vector or just in terms of midpoints? No, that one must also be determine the midpoint or just midpoints like that. So midpoints you just represent them in coordinate form, isn't it? But there are some situations whereby they will tell you to represent the position vectors of the midpoint, isn't it? So if they are position vector, you simply put ix plus yj plus zk, then you substitute the value. X is this, y is that, z is that, isn't it? So there. Good. What is midpoint of vector C? What is C? C was a minus b. Meaning it is from b to a, b a second minus first, isn't it? So from b to a, so the midpoint, you are looking for the midpoints of this, isn't it? What is the midpoint of x? It is 3 plus negative 1. Divide by 2, you get the x value in the middle, isn't it? 1. 3 plus negative 1 is 2. 2 divided by 2 is 1, isn't it? Then what is the middle y value here for C? 1 and 3. 1 plus 3 is 4, meaning the middle y value is 2. 4 divided by 2. Very good. Then what is the middle z value for C, for vector C? Negative 2 plus 4 divided by 2, you get 1. Then in the end, you found the midpoints of the 3 vectors. Is this concept well understood? It is very direct and very simple if you compare it with the other method, which I don't want to get into because I want you to deal with the things which are direct and straightforward, okay? Are we together? Very good. So that is how to prove that given vectors form sides of a triangle and how to determine their midpoints. For you to show that the form size of a triangle, if you are given vector A, B, and C, it doesn't mean you label the triangle ABC. No, vectors must be relative to the origin, meaning one point must be the origin. Are you seeing that? Then you express one vector in terms of the other two. Is that okay? Very good. So that is how to handle that kind of problem.